Hello everyone, this is Mrs. Kostelecki. Welcome to AP Stats. Today we will discuss what does 95% confident mean? In other words, what is a confidence interval? To do that, I'm going to use this applet that's listed in this first sentence here, and I'm going to bring that up right now along with these settings here and kind of follow along with this page. So here's the app. I've already got it set up, so I want 0.5 for my population proportion, 95 for my confidence level, and 75 for my sample size. So for number 2, it says click sample. So I'm going to click sample. And there's my first confidence interval. Just made the confidence interval for me. Did it capture the true proportion? Well, we said the true proportion is 0.5. And notice that 0.5 is inside my interval. So yay, it did capture my true proportion. If I repeat this 10 times, so 1, 2, 3, 4, 5, 6, I don't think I counted right. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here's 10 samples. Out of those 10 samples, 9 of them captured the true proportion. Notice this red one that looks like it's got a, like a point estimate and maybe 0.38, did not capture the true proportion of 0.5. It missed it. So this is an example of kind of a demonstration of a confidence level where we have 9 out of the 10 that captured the true proportion. If I do, so then in number 3, it says reset, and we're going to take 100. All right, so if I take 100 samples, I'm going to go 1, 2, 3, 4, 100 samples. And you can see down here it says total, there's 100. 93 of them hit. Okay, well, I wanted a 95% confidence, and I can't really, well, can I? No, I can't really show this on with my cursor, but we chose a 95% confidence level, and when I did 10, only 9 of them captured the true proportion out of 10, so that's like 90%. Now, when I do 100, 93 of them captured the true proportion, which would be like 93%. So if you kind of take this along with like when we do many samples, we get closer and closer to what the true proportion should be. It's kind of like that with confidence intervals. If we take more and more confidence intervals, we should get closer and closer to that confidence level, which means we should get closer and closer to 95% of our confidence levels capturing the true proportion. In number 4, it says, watch your confidence intervals as you drag the confidence level from 95% to 99%. Don't reset. So I'm just going to use what I have here, but instead of having 95%, I'm going to drag this to 99%. Hey, it's a subtle difference. I'm going to go back to 95. What happened? 95, 99, 95, 99. Hey, if you look, the intervals got wider. And so, and if you look for this particular example, 100 of them out of 100 captured the true proportion. So we actually have like 100% that captured when we chose a 99% confidence interval. Now, think about it. If the confidence interval itself is wider, are we going to be more confident that it's going to capture the true proportion? Yes, because it's wider, so it has more space and it's more likely to capture more numbers, which would be including the true proportion. So when we have a higher confidence level, we get a wider confidence interval, which is more likely to capture the true proportion. If we go to number 5, and we're going to hit reset this time, and we're going to change it to an 80% confidence interval. So we're going to go way down here, 80% confidence interval. And I'm going to do this 100 times. So 1, 2, 3, 4. That should be 100. So now if you look at my hit out of total, it's 78 out of 100. We're very, very close to that 80% mark. So 78% of our confidence intervals actually captured that true proportion of 80%, or the 0.5%, or 0.5, excuse me, was the true proportion. Basically what's happening here is if we take many, many confidence intervals, our confidence level indicates how many confidence intervals we would expect to capture the true proportion. So if we have an 80% confidence interval, or confidence level, then we're expecting to capture about 80% of the confidence intervals will include the true proportion. So notice, I don't know if you can tell here, I'm going to move my confidence level. When we went to 99%, the confidence intervals got wider. If I go back to 95, look at the difference between 95 and 80. 95, longer confidence intervals, 80, shorter. So because it's a shorter confidence interval, it's harder for those confidence level or intervals to capture that true proportion. So that's just kind of going through all of that information from that front page. In number 6, it says, now we will see what happens when we adjust the sample size. Change the sample to 20. So sample to 20. And sample for one interval. Okay, and I think I still want to be at 80%, it looks like. So if I do it for one interval or one sample, there's my confidence interval. Okay. If I change it to 250 in sample for one interval, so there's my sample size of 20, and now I'm going to change it to 250. There we go. And I'm going to take a sample. It's much harder to see because we can't show them at the same time here. I can't toggle back and forth. But if you look at this interval is much narrower. So in other words, as the sample size goes up, our variability of our sampling distribution goes down. It's a lot shorter. It's a lot narrower. Okay, let's go back to this front page. And we'll try to remember some of this stuff that we saw. For number 4, a couple of notations I want to make. Number 4, watch your confidence intervals as you drag the confidence level from 95% to 99%. Don't reset. What happens to the intervals when the confidence level is increased? So right here, if your confidence level, oh my goodness, I cannot write. Okay. If your confidence level goes up, then your margin of error also goes up. In other words, this margin of error, remember, is how far to the left and the right of that middle value the point estimate is. It's going to make it longer. The confidence interval itself will become bigger. For number 5, down here, interpreting the confidence level. So here's our interpretation. If we take many samples and calculate a confidence interval for each, we expect about 80% of them to capture the true population proportion. Okay, this looks terrible though. This should be capture. Okay, so basically whatever our confidence level is, we expect that percent of them to capture the true population proportion. For number 6, as our sample size increases, our margin of error decreases. And if our margin of error decreases, that means our confidence interval also decreases because margin error dictates how wide that confidence interval is. Okay, so let's fill these notes in. Okay, interpreting the confidence level. So I'm going to kind of repeat what I already wrote. Oops. Our first section here is interpreting confidence level, which is different than the confidence interval. Okay, here's our interpretation, which interpretations are always going to be super important, so probably highlight this or something. If we take many samples and calculate a confidence interval for each about blank percent of them will capture the true, and then we're going to put in, it's either going to be your parameter for population or your parameter for your mean, and then in context. Okay, so this is your parameter. Always in context, always, always. Okay, so that is interpreting your confidence level. So basically, what percent of them are going to capture the true proportion? What percent of your confidence intervals are going to capture the true proportion? Middle section. Margin of error. Okay, so if your confidence level goes up, then your margin of error is also going to go up. And that is because we have a wider interval. If your sample size goes up, then our margin of error is going to go down, and that is because we have a narrower interval. Last section here of our notes. So margin of error does not, oh, I lost my pen, excuse me, does not, oh, shoot, sorry. I want to word this differently, sorry. Margin of error does account for sampling variability. Okay, but it does not account for these things. It does not account for, okay, so these are no's. It does not account for this. Non-response, undercoverage, or response bias. In other words, your margin of error is going to account for sampling variability, but that's if we have independent samples and we're taking good sample sizes, all of that kind of stuff. It does not account for taking bad samples. If you have bias in your sampling because you didn't do a random sample, if you have non-response, if you have undercoverage, response bias, then you have to go back to the drawing board and take better samples because it's not going to account for the variability due to these. So be careful of that. You still have to have good sampling practices. Okay, I'm going to end the notes here. Try the check your understanding, give that a try, and then we will talk more in class. Thanks for listening, everyone.